So in this particular topic, it says solving one-step equation. The reason why it's one step is because there's only one step that we're going to do that to figure it out. Okay? But before we get to that one, I want to ask you this. Let's see if we can figure out the answer. Let's see if we can figure out the answer here. Is there somebody at the principal? Let's see. We're trying to get into the algebra part here. This is what the algebra is. It's solving for something. X plus 5 equals to 12. So sometimes I call this a backwards question because it's not the answer over here. The number here is missing. Come on in. Okay, so something that you add 5 to will give us 12. So what would that be? So something that you add 5 to will give us 7. Okay. So 7. Okay, yeah. Have a seat. So we know it's 7. Okay. Well, how did you figure that out? How did you figure that out? What did you do?
12 minus 5.
Okay. Betty said 12 minus 5, and she was like pretty confident with that, and that's correct. 12 minus 5. Okay. But the thing is, the thing about this is like, I don't see 12 minus 5 in this statement. So where did that 12 minus 5 come from?
Convert the plus sign into a subtraction. Slap it in between equals 5 equals 12.
Okay.
Opposite.
The opposite. Okay, very good. So we're starting to piece all the things together. Okay. So Sean said he sees a plus 5. He sees a plus 5 here. And then he's saying he's going to reverse the plus 5, which is the opposite of that is a minus, right? Okay, which again connects to what Betty had talked about earlier. 12 minus 5. Okay, good, good. Awesome. Okay, now let's try this one. How would you answer that question? Something, and then you take away 3 will give us an 8. Something, a number, and then you're taking away 3 from that number is going to give us an 8. What do you think that is?
That's isolated. The X is isolated.
Okay, you just got it, and then you're already, we're going to talk about that isolating something. That's something that I will discuss in a few moments. Okay, so how would you, what do you think the answer for this one? 11. 11? Not sure? 11? Okay. Now, how, let's say you say a number, 11. The number is 11. How do you know if the 11 is the correct answer? How would you know if your answer is correct?
8 minus 3. Question mark. So you would add.
It would have been 11 minus 3 equals 8.
Yeah. So in the back of in our mind, we said our answer is giving you a strategy yet, although I think some people already have some kind of a strategy. That's good, so we're gonna get into that in a second. Okay, one more. Maybe two more. Now, what operation is that brackets there again? What is that one? Multiply. Okay. So what does that statement say? 2 times something, whatever that something is, will give us a 6. So 2 multiplied by something, which we kind of trying to figure that out, will give us 6. So what's that one?
2 times 3
2 times 3.
equals
2 times 3 is equals to 6, right? Okay. So that's good. Okay. Can I give you one more? One more.
no ahead.
Well, what? Go ahead. Okay, you're already up for the challenge. I like that. Here's the other one.
Fast is
You're gonna have 12 divided by something, whatever that something is, will give us 6. Well, we divide that by something, and then the result will give us 6.
12 divided by 6.
12 divided by 6?
No. 12 divided by
2. Okay, 12 divided by 2.
12 divided by
12 divided by 2. And you know that because when you substitute that value in there, it's gonna give us 6. Okay? Now, this is just the mental math, something that you just kind of thought of, right? And they're not that bad. We could do mental math here. But then, what we're gonna do, and we're gonna learn today how to do a process. Because some of the questions is not gonna be as easy as that, right? They're not gonna be as straightforward as that. So we need to find a strategy on how to do that. Because sometimes we change a number what if it's like that? Okay, we gotta find a strategy. So I just changed it a little bit. So we gotta find a strategy that would work all the time. Okay? So, yeah, don't figure that out because I will have to talk about strategy. So I like what I'm hearing about you solving this. Okay? So, here's what we're gonna do. The topic is called solving one-step equation. Solving an equation. Solving an equation. So, I'm gonna ask this. Well, what does the title say? What does the title mean? Solving means to. It could include plusing or adding. It may be other operation. What does it mean by solving? We're trying to figure something out. Okay, we're trying to solve, we're gonna try to figure it out. Solve it out, right? Figure out something. One step, because we'll talk about there's only one step that we're gonna do to do this. Okay? One step operation maybe. And then equation. Now I'm gonna do the equation here. Equation. What is an equation?
Something not equals.
Equation. There's a difference between an expression and an equation. Equation is when you have two expressions, two mathematical expressions trying to equal each other. Okay, so equation is when you have two expressions on each side. You'll see a root word there is equal. So there's some kind of an equal side between the two expressions. So equation is you have an expression here equals another expression here. Okay? Equals equation, there's an equal sign in between. Equation has equal sign in between. Well, what does it mean by equal? They're same in value or equal in value. So that's an equation, right? So we know what an equation is. When you have one expression on the one side, okay, and another expression on the other side, and then there's an equal side, an equal in between that. So that's an equation. What else can I tell you? Somebody had said this. Somebody had mentioned something earlier, is the opposite operation. What is an opposite operation? In every mathematical operation, there's going to be an opposite to it. Okay? So there's every mathematical operation, there's an opposite operation to cancel it off, to undo it. So when you have the adding, what's the opposite of that one? Subtracting. So these two are opposite operation of each other. So adding and subtracting, opposite operation. What about multiply?
Division.
Division. Division is the opposite. I'm going to write this down, but we might see it later on anyway. What is the opposite of squaring? Squaring, the opposite is square root. Okay? Squaring, or to square a number, the opposite of that is square root. What about cubing? Let's see, cube root that. Yeah. Okay, so these are some of the operations that we know of, right? That we're familiar with. Okay, so if we want to undo something that got added, we have to opposite, which is subtract. Now, I'm gonna ask a volunteer to go to the front. Okay, no, you're not figuring out anything math related stuff in here. Just be one volunteer. One volunteer. No math involved.
I'll do it.
Okay. I know it's like sometimes like to move forward 2 steps. Okay, move forward 2 steps. 2 steps forward. How can she go back to her original place?
Move back 2 steps.
Minus 2 steps.
1 step forward, 2 steps back.
Yeah, 2 steps forward to get back to the original place. She has to move 2 steps back. Okay, 2 steps back. Okay, we're like line dancing in here. Okay, good. What did you notice there?
Equals.
Opposite.
Opposite.
Opposite. 2 steps forward. The opposite is 2 steps back. Think about that. Just like what we were doing in here. Okay, we're not. No.
Oh, it's like already done.
Okay. Now I want Kayla to move 3 to the left from your original. 3 to the left. Okay. How can she get back to her original place?
Back 3 steps to the left. To the right.
To the right.
3 steps to the right. Okay, do it. Okay. What do you notice?
It's the opposite.
Opposite. 3 steps to the left. The opposite is 3 steps to the right. What happens if she didn't follow that? What happens when she doesn't follow that? She moved 3 to the left. Okay. What if she went 3 to the left again? Would she go back to where she was? No. 3 to the left again. No, left. 3 to the left. Did she get back to her original place?
No.
No. So,
3 to the left.
thank you. Give her a hand. Good. So, what is the point of that exercise? Well, that exercise is to get back to where you were, or to figure out what you started off with. You have to do the opposite of what was done. Undo what was done prior. Okay? Good. Give that a try. Okay, good. So, we talked about equation. You have something here equals something there. What we're trying to do is to maintain the balance between left side and the right side. This is our left side of the equation, left, and then this is the right side of the equation. Left side and right side always have to balance. Always. Okay? Because if it's not balanced, then they're not equal. Right? So the left side is equal to the right side. Another thing that we have to do is this. What you do on one side, you gotta do it on the other side. Right? If you add 3 here on the left, you also have to add 3 on the right. Okay? It's like a scale. When you add 3 things in here, it will change the balance. You have to do the same thing on the other side. Okay, so the other thing that we talked about, somebody brought this up. Okay, let's actually write that down. What we do on do
on one side of equation, we must do it on the other side as well. We must do it on the other side as well. Okay, so that's how we keep the balance, to maintain the balance. Now, one student here said isolate. What does isolate mean?
For example, this is x plus 2 equals 9. So we isolating the x. 7 plus 2 equals 9.
Okay. Oh, we're gonna get into that example later. You're getting ahead of me. That's okay, Jabbar. Isolate. What does the word isolate mean?
Is leave it alone.
Leave it alone. Yeah, have it alone. So, have the variable alone. Okay, well, I'm writing the word variable here. Variable, that's the x, something that's we don't know, right? Have the variable alone by itself. No other number beside it, no other number with it, just by itself. That's what it means by isolate. Okay, so we haven't really done a lot of things in here yet. We talked about what is an equation. We talked about what's the equation, means the left side, and there's a right side, and there's an equal side in between. That's what equation is. And we said that we're gonna do an opposite operation. We see adding, there's a subtraction that we're gonna do. If you see multiplying, there's a division that we'll do. Squaring, there's a square root that we'll do. Cubing, there's a cube root that we should do. We're really not gonna focus on these ones today, although maybe later on we will. Okay? And then we talked about isolating the variable. That means keep making it alone by itself. Okay, so I know you're pretty excited about the notes, so let's get into that one. Here. So we're pretty clear on what equation is, right? So learning how to do basic operations with numbers helps us to solve math equations. Equations can be simple. Okay, we've seen like a few examples of simple equations that you can do it in your head and require only one step to solve. Or they may be a little bit more challenging, more difficult. It involves 2 or more steps to solve. So we'll learn all that stuff today and maybe tomorrow. So equations are used to represent number problems that we might encounter in our daily lives. An equation is made up of 2 math expressions, so we talked about that. 2 math expressions connected by equal sign. So you got 2 math expressions, we got one on the left of the equation and then one on the right of the equation. Letters called are variables, and it represents a number that we have to figure out, Okay, so variables are used to represent the numbers that are not known. Any letter from the alphabet can be used as variable, but it's very common that we use X. So in the first few examples that I did at the beginning, I just put X, right? It could be M, it could be Y, it could be A, but X is usually the case. To solve means To solve an equation means to find the number that makes the equation true. In other words, to make both sides of the equation equal to each other. So that's what it means to solve it. We're going to look for a number that makes the equation true. That the left side is going to equal to the right side. This means that when we substitute the value into the equation, the left side equals the right side of the equation. So we talked about that. So some stuff that we've already discussed are here. When we solve an equation, we isolate. We isolate means have things by itself. Have the variable by itself. So that is sitting by itself on one side of equation. We'll practice that using solving equations in here. So it says here, here's our example 1. Now, I'm pretty sure you could figure this out without the process, right? What do you think the answer is? 7. Okay. There's no process there, right? You just know because you know a lot. You know, you have a lot more background in math, right? But now I'm gonna show you how to the process. How's the process here? Okay. What we're trying to do is to isolate x. I'm gonna isolate x. Have it alone. Okay. What's happening to x? Got added by 2. Got added by 2. So we have to look. Well, if this x got added by 2, the opposite would be subtracting 2 or minusing 2. Right? So I'm going to minus 2 in here. Now, if I minus 2 on the left side, I have to do the same thing on the right side. Right? So if I take away 2 from here, I must take away 2 from this side as well. Okay? We said that. It says here, get back here. What we do on one side of the equation, we must do it on the other side as well. So minus 2 here. So positive 2 or plus 2 and minus 2. That's 0, canceling it out. So what's left? We're left with x equals, then what about this one here? It says 9 minus 2. It's going to give us the 7. So here, we must isolate the x variable. We must isolate the variable x. To do that, we have to do the opposite of adding 2. Okay, so we have to do the opposite of adding 2, which is subtracting 2. Okay, so this is my train of thought. This is what I'm thinking, and I'm just writing it in words here. Okay, but I have to subtract 2 on both sides of equation. Okay? So that's the first part. We must isolate it. To do that, we do the opposite operation, and we have to do it on both sides. Good? Now this, like I said, this is a one-step equation. The only thing that we did was subtract 2. Right? It's one-step equation. Do you have room here still? On the side? I have a little bit of room. What we're gonna do is we're gonna do the checking. So how do we check our work? How do we know that it works? So we have the left side and we have the right side. LS, left side, RS, right side. Okay, so we said X is equals to 7, right? So X plus 2 equals 9. We just figured out X. X is 7, so we're going to put 7 there. Plus 2 equals 9. And then you go 7 plus 2. Yeah, that's 9 equals 9. Is 9 equals 9? Yeah.
Teacher, is that okay when I was solve the problem X example 1? X 2 plus 7 equals 9. Is that otherwise? Is that one other ways to help?
Oh, you just went 2 plus 7
Yeah.
equals 9? Yeah, you could change these two, but yeah, what we're gonna do is we're gonna try to keep like following with the original one as much as we can, because we don't wanna mix things up. Okay?
Does it have to be set up in that kind of category?
The checking or this one?
Or
Yeah. The solution, like this part? Yeah. This one here, what we're gonna do is we're gonna practice the process of doing that, because this one's pretty easy, right? So what we're gonna do is we're gonna practice the process. So yeah, let's get into that. We're creating a habit in terms of that. Oh, okay, so you're already, so what you're doing is, yeah. Take two, cancel. And then so the equal sign are right here, and then that's 7. So there's always the left side equals to the right side. This one you got a left side and a right side.
And if I were to go opposite,
Yeah. Here we've lost the x,
yeah,
right? Okay. So we want to say x is equals to 7.
sure.
Yeah. I think you got the idea. It's just that we want to make sure that we keep the x in our equation.
Good.
Good. Okay. So we're practicing the process. Let's try this one. What are you thinking about when you see this? X minus 12 equals 31. Okay, I have to isolate the x. And how do I isolate the x?
Leave it alone.
Yeah, and how do we do that?
So cancel the X.
Okay, so we want to, no, we
Yeah.
don't, yeah, we want to have the x alone.
Yeah.
So we see this, it's x minus 12.
Yeah.
X minus 12.
Minus 31 minus 12.
Okay, remember the opposite. Okay, I see a minus 12 here. So what are you going to do?
12 plus 13.
Plus 12, yeah. So I'm going to add 12. Add 12. Okay. Because I think some of you probably already know the answer here. Okay, So x minus 12, I'm gonna have the x alone. So I have to do the opposite of negative 12 or minus 12, so plus 12. And I gotta do it for both sides. Cancel, cancel. What's left over on this side? We're left with x. And what's this one? This is gonna give us 43, okay? And as you can see, the answer has x equals to it, right? X equals to 43. And how do you know if your answer is correct? Left side equals to right side. Left side is x minus 12 equals to 31. We just figured out it's 43, so we're gonna put 43 here. Okay, and this one is still 31, and then you go 43 minus 12, it's 31 equals to 31, so yes, it's correct. Is that good? Put it back. Take a few more examples for sure. Oh, here? Sorry, forgot the one. Thank you. You can solve any problems that's something like this if we go through the process. Is it okay to move to the next page? Is it? Okay, what about this one? What can we do here? The x is there, so what do you think we do to solve for x? 54 plus something will give us 75. Okay, yeah, you're giving me the answer already, but what's the process? What are we going to do? Yeah, the 21 is the correct answer. It's a process. So I see 54. Yeah, subtract with what? 54. Subtract 54. Excellent. So subtract 54. Oop.
58.
Not 58. I don't know where that 58 came from. 54. Subtract 54 on, but I gotta do it on both sides, right? Because both sides, we have to keep it balanced. What you do on one side, you gotta do it on the other side. Cancel, cancel. So 54 minus 54, that's 0. They cancel each other out, so you're left with x is equal to 21. Excellent. Good, good, good. What about this one? What do we need to do? Not the answer. I'm not interested in the answer yet.
Use the first one.
Okay, what's it?
Minus 122.
Minus, or subtract 122. I do it on both sides, so negative 122, or minus. So these cancel. What's left over? X is equals to, oh, I gotta do my math there, right? So 91 minus 122.
Plus 30.
Let's see. 91 subtract 122. Minus, yeah. Yeah, we're going to put a minus there. Minus 31. Negative, or negative 31. Okay, this one is slightly different because it has a negative number in it. Let's go check. Let's check our answer for this one, okay? Let's check our answer. Left side has to equal right side. What does the left side say? 122 plus x equals 91. Okay, I got 122 here plus negative 31. And then the right side is still 91. Let's work that out. 122 plus negative 31 is equals to 91. Yeah. So the answer is 91.
And if I forgot to slap the minus 31,
Yeah.
mess up the whole thing.
That's right. That's it. I was thinking about that. And that's a great thing about the checking is that what if I forgot? What if I forgot the negative 30 negative there? What would my answer be? It would be, this is my wrong answer, okay? I don't want to write it there. What if I forgot 122 plus, and I forgot the negatives, I just go 31. And I figured this out, that's going to give us 153 equals to 91. Okay. That kind of gives us an indication that there's something wrong in here. What's something wrong? What's the wrong thing about this? With the answer.
It doesn't balance.
It doesn't balance. They don't equal. They don't balance, they're not equal. Well, what's wrong with it? It's because this is not the right number. It has, yeah, we have to put in the right number. That's a good, I'm glad that you bring these up, right? Because those are important. Okay, example 5.
I'm surprised I even have to.
Hmm?
I'm surprised I even thought of it.
Well, I think it's because you're thinking and not just doing what I tell you to do, right? Yeah. Okay, let's do the last two and then I think we're okay. What are we gonna do here? Is
Isolate.
Minus.
minus 24. Subtract the 24 because this is x right here. And then we want to isolate that. So it's minus 24. I got to do minus 24 on the other side as well. This is gone. This is gone. Okay, what's that equal to? 543. 543. Good. If this is an equation or this is an assignment question, this would be most likely 2 marks. Okay, it's gonna be 2 marks, and I'll tell you why it's 2 marks. 1 mark for showing the work, this part, and then 1 mark for the final answer. Okay? Take a look at the example number 6. Oh, wait. Yeah, sorry. Yes, it's good now? Okay, good. Last example, what are you going to do? What's your strategy to solve for x?
So can you go to the first one?
Negative 13, 577.
Okay. Negative or subtract 13,577. If I do it in this side, I got to do it on the other side, so negative 13,577. This cancels. So x is equal to
12,001.
12,001. Is that a positive or negative?
It's a positive.
It's positive. Yeah, positive. Good. Awesome. Okay, I'm gonna stop right here. Okay, just to recap what we talked about. This is an equation. There's a left side. There's a right side. I'm gonna stop here. We want to isolate the x. So to do that, we do the opposite operation of what we see. And then you do it on the left side and on the right side. Okay, so this is for now. Stopping right there.